Hi everyone, I am Santi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 32 from linear algebra on eigenvalues, eigenvectors and diagonalization. In this lesson, I am going to explain about diagonalization of a matrix. Here is the procedure to diagonalize a given matrix. First one, let A be a square matrix of order n. Point number 2, check whether A is diagonalizable. In previous lessons, we discussed how to check whether a given matrix is diagonalizable. So then number 3, if A is diagonalizable, then what do we get? We get the following two. First one is a diagonal matrix D with eigenvalues of A as diagonal elements. And point number 2 is an invertible matrix P with eigenvectors as its columns. So if A is a diagonalizable matrix, you will obtain these two matrices D and P. Then next point is to diagonalize A, we will show that AP is equal to PD. Because if AP is equal to PD, then it means that A is equal to PDP inverse. That's what we mean by diagonalizing a given matrix. Now let us look at an example to diagonalize a given matrix. So here you are given a matrix, a 3 by 3 matrix A with its eigenvalues lambda is equal to -1, -1, 5. These are eigenvalues of A. So eigenvalues are already given. So what do you have to do? We have to find the eigen vectors. So lambda is equal to -1, 5 are eigenvalues of E. Then we have to find eigenvectors. We have to find the eigenvectors. So consider first one eigenvector for lambda is equal to -1. Let x be an eigenvector for lambda is equal to -1. For the eigenvalue lambda is equal to -1. That implies the equation A minus lambda I into x is equal to 0 has non-zero solution. That implies that is A minus -1 into I into x is equal to 0 has non-zero solution. Now first let us write what is considered. A minus -1 into I is equal to. What will be A minus 1 and this one will be? So the same A matrix A, but in the diagonal you have to subtract. This is A is this 0, 1, 1, 2, 1, 2 and then 3, 3, 2. Then in this you have to subtract in the diagonal element -1, -1, -1. This is A minus lambda. What will be this one? This will be equal to 1, 1, 1, 2, 2, 2 and then 3, 3, 3. This is A minus lambda. Now what will be x now? Let x is equal to, since it is a 3 by 3 matrix, we'll consider x1, x2, x3 be eigenvector. This is what you have to find. So you have to solve. So now to solve system of equations A minus lambda I into x is equal to 0. So for this consider augmented matrix. Consider augmented matrix A minus lambda I comma 0 So what will that be? That is equal to 1 1 1 2 2 2 3 3 3 0 0 0. Reduce. Let us quickly reduce it to echelon form. So this is, so for R2, R2 minus 2 R1, and then for R3, R3 minus 3 R1, we get the matrix 1 1 1 0 2 minus 2 0, and this is also 0 0 0, and then this all will be zeros. Now this is in echelon form. This is in echelon form. Now we have to find x. We have to find x. So this is R1 row 1. Only row 1 is a non-zero row, all the others. So I have R1 implies, I will write here x1 plus x2 plus x3 is equal to 0. Then only this equation you have it with you. So you have to suppose, then let it be equation 1. Then you have here x1 is equal to any two variables, only one equation, two variables you have. So you take, let x2 is equal to k1 and x3 is equal to k2. I suppose that x1 is equal to, x2 is equal to k1 and x3 is equal to k2. That implies I have x1 is equal to minus k1 minus k2. So now I have all the three values. X1 is minus k1 minus k2 and x2 is k1 and x3 is k2. Therefore, eigenvector x is equal to x1, x2, x3. That is equal to, you have here x1 is minus k1 minus k2 and x2 is k1 and x3 is k2. So this will be equal to this. I will write it as, how can we write this one as k1 if you take common minus 1 1 0 plus k2 if you take common minus 1 0 1. That implies these two will be the eigenvectors. Minus 1 1 0 and minus 1 0 1 are eigenvectors for lambda is equal to minus 1. Now let us look at to find eigenvector for lambda is equal to 5. So the same procedure here I will take, consider a minus lambda I into y is equal to 0. So where y not equal to 0 is eigenvector. Right. So I will take, let y is equal to y1, y2, y3. Now let us see what is a minus lambda I, that is a minus 5i is equal to, we have a is 0 1 1 and then second row is 2 1 2, third row is 3 3 2, then subtract here minus 5 minus 5 minus 5. So this is nothing but minus 4 1 1 2 minus 4, this is minus 5, sorry. This is equal to minus 5 1 1 2 minus 4 2 and 3 3 minus 3. Now consider augment. To solve, you have to solve this. Consider augmented matrix. Augmented matrix A minus Lambda I means 5i comma 0. That is equal to minus 5, 1, 1, 2 minus 4, 2, and then 3, 3 minus 3, 0, 0, 0. Now reduce it to echelon form. So I think we can simplify it more. I will do first for R2 divide R2 divided by 2, and for R3 divided by 3. So this will be transformed to minus 5, 1, 1, 0, 1 minus 2, 1, 0, 1, 1 minus 1, 0. Now this is the pivot position. Then let me write this to have to make zeros. But instead I can do one more thing. I can interchange for R1. It will be easy. R1 to R2. Anything you can do. So I will get here 1 minus 2, 1, 0. And then minus 5, 1, 1, 0. And then 1, 1 minus 1, 0. Now again mark the pivot position. So now for R2 plus 5 R1, and for R3 minus R1. So this will give me, so it is 1 minus 2, 1, 0, and then 0. R2 1 minus 10 is 1 minus 10 is minus 9, and then 1 plus 5 is 6, 0, and then 1 minus 1, 0, 1 minus of minus 2, 3, and then 1 minus 1 is minus 2. Next one. Now this is pivot over now. This is a pivot. Before that I can divide this with 3. So make for R2 divided by 3. Then this will be transformed to 1 minus 2, 1, 0, 0 minus 3, 2, 0, 0, 3 minus 2, 0. Now the work will be simple. This is pivot for R3 plus R2. Add these two elements. So this will be 1 minus 2, 1, 0, and 0 minus 3, 2, 0, 0, 0, 0, 0. So why this echelon form is completed? This is R1, R2, R3 is a 0 row. So R1 implies you have y1 minus 2y2 plus y3 is equal to 0, and R2 implies minus 3y2 plus 2y3 is equal to 0. Now you have to solve all these then you have just let me give it equation 3 and 4 whatever are given earlier. So here I will solve this. I will take 4 implies minus 3y2 is equal to minus 2y3. That implies y2 is equal to 2 by 3 y3. This is equation 5. Substitute 5 in 3. So you will get y1 minus 2 into 2 by 3 y3 plus y3 is equal to 0. So solve this. Y1 is equal to 4 by 3 y3 minus y3, which is equal to 4 minus 1 to y3 by 3. It is equal to minus 3. So it is 1 by 3 by 3, which implies I have y1 is equal to 1 by 3 y3. Now earlier you got this is 6. Earlier in equation 5 you got y2 in terms of y3. Now in equation 6 you got y1 in terms of y3. Therefore we have the eigenvector y is equal to, which is y1, y2, y3, where y1 is 1 by 3 y3, and then y2 is, what did you get here in equation? 2 by 3 y3, 2 by 3 y3, and y3 is y3. So you can take common y3 by 3. If you take common, we'll get it as 1, or our first instance, let us write y3 only. You take common y3, if you take common 1 by 3, 2 by 3, 1, or you can say it is equal to k into, so if you multiply with the 3, then it will be 1, 2, 3. Implies y is equal to 1, 2, 3 is the eigenvector for lambda is equal to 5. Now what are the 3 eigenvectors you got? And therefore eigenvectors of A are first 2 vectors. What are the first 2 vectors? Minus 1, 1, 0, and then minus 1, 0, 1. These are for lambda is equal to minus 1, and 1, 2, 3. These are the 3 eigenvectors that you got. Now what is your task? Now we have to check for the diagonalizability, how to, and then to diagonalize a matrix. If a matrix is diagonalizable, then only you will diagonalize it. So consider P is equal to, matrix P is equal to, in this P will take these 3 whatever the eigenvectors you got as columns. Then what is the det P? Det P is equal to, so expand the determinant, minus 1 into 0 minus 2 plus 1 into 3 minus 0 plus 1 into 1 minus 0, which is equal to 2 plus 3 plus 1 is equal to 6, not equal to 0. That implies the eigenvectors are linearly independent. If they are linearly independent, then by diagonalization theorem, A is diagonalizable. So now, see, if it is diagonalizable, then you will diagonalize it. So now to diagonalize A, we have to show that AP is equal to PD, where P is the matrix with eigenvectors, and D is the diagonal matrix with eigenvalues as entries in the diagonal. That is, so we have P is equal to, what is P we got with the vectors? Minus 1, P is equal to minus 1, 1 0 minus 1 0 1 1 2 3, and D is equal to diagonal matrix. What is a diagonal matrix? Only the diagonal entries are non-zero, all the other entries are zeros. What are the diagonal entries then? What are the eigen values here? D will be equal to minus 1, minus 1, 5. The eigenvalues are given. Lambda is equal to minus 1, 5. And minus 1 has got 2 eigenvectors, 5 has got 1 eigenvector. That means minus 1 is repeated twice. So minus 1, 5. And the remaining elements are not zeros. 0, 0, 0, 0, 0, 0. Now let us say what is A into P. A into P is equal to, so A is 0, 1, 1, 2, 1, 2, 3, 3, 2 into P is equal to minus 1, 1, 0, minus 1, 0, 1, and then 1, 2, 3, just to find the product. So this is 0 plus 1 plus 0, 1, and then 0 plus 0 plus 1, which is equal to 1, and then next one is 0 plus 2 plus 3 is 5, and then minus 2 plus 1 is plus 0 is minus 1, and then minus 2, 0 plus 2 is 0, 2 plus 4 6 plus 6 2 plus 2 4 plus 6 is 10, and then next one is minus 3 plus 3 0 plus it is 0, and then minus 3 plus 0 plus 2, minus 3 plus 2 is minus 1, and then 3 plus 6 9 plus 6 is 15. This is 80. And then let us see what is PA also. Not PA, PD is equal to, so P is equal to, now you have minus 1 minus 1 1 1 0 2, and then 0 1 3 into D is minus 1 0 0 0 minus 1 0, and then 0 0 5. Multiply this, you will get here minus 1, and then next one will be 1, and then that other one will be 5, and then minus 1 you will get, and then 0 0 0 0, and then you have 0 0 10, and then 0, then 0 minus 1, and then 0 0 15. So this is what AP is equal to PD, where AP is equal to PD. This is what to diagonalize a given matrix. So you will work out now a practice problem. Practice problems. So first one is A is equal to, first one is A is equal to 2 0 minus 2 1 3 2 0 0 3, where lambda is equal to 2 3, and the second one is A is equal to 2 minus 1 1 4, and then here lambda is not given, you have to find the lambda, and these questions are for diagonalize the following matrices. And then next, the third question is A is equal to 1 2 minus 3 2 5 minus 2, 1, 3, 1, where lambda is equal to 0, one of the eigenvalue is given here for you.